Now today we saw drones, we saw robot races, and even robot dogs. But seeing a solar-powered vehicle designed and built by high school students is absolutely groundbreaking. But now, from solar car to solar train, Mr. Tladi Mashiane is not only the acting vice principal of the Soshanguve Automotive School of Specialization, but he is also an educator who believes in giving kids the time, the support, and the space that they need to showcase their skills and talents in solving the current day challenges in the automotive space. Please welcome on stage Mr. Tladi Mashiane.
More again to thank the organizers, Sasol especially, to make it possible for us to come to this place, to come and present what the learners has done in our school. I am Tladi Mashiane. Currently, I'm the acting principal of Soshanguve Automotive School of Specialization. The school is situated in Soshanguve, one of the well-known townships in Pretoria. I'm not alone today. I'm with my co-learners, who I'm going to present this solar train. And my name, as I said, I'm going just to give the background of the school. And Ronnie will do why solar train. And Princess will do the development stages of the train. And Letabo will do the curriculum-related subjects, inspiration and motivation. As I've said, that the school was launched or was officially opened 1985, and the school was named after or called Soshanguve Technical Center. During that time, the school was offering practical subjects. It was woodworking, electrical, and mechanical for the learners from the primary schools. They used to come there in the afternoon to do what we call extra curriculum, to learn the skills of how to operate in terms of the fields of trades. And in 1996, the school was converted to a technical school, whereby it was administered by the GDE, Gauteng Department of Education. And in that time, the school offered the subject, technical subject only. Mathematics and physical science were the main core subjects. 2019, the school was also chosen amongst the 9 provinces to facilitate as a pilot for the National Merisita Artisan Program, whereby we registered 19 learners, and all by now, as I'm speaking, they are qualified artisans. The school have contributed to the NDP Vision 2030 for the country. Now, when you talk about us, as I've said, that my belief is that give the learners a space, support them, provide with all necessary equipment, then you can see how can they showcase what they are made of. In our school, we believe that learners are the solution makers of this country. We have also the subject that we offer at the school level. In terms of the academics, we've got all the trade subjects: civil, woodworking, mechanical, welding, electrical. And also we have extra curriculum that we are offering during the after hours, which are the coding and robotics, drones, piloting, 3D printing, entrepreneurs, intervention classes, and also we have the computer program system at school. And currently, the main project that we were busy with is the one that we call innovation project, named under Solar Train. That one is still a school background that gives the history of the school, that tells us more in terms of the community skilled-based education. We also offer the community the skills in terms of the mechanical, civil, and woodworking. Right, in 2019, on the 9th of April, we were fortunate to be also launched as a school of specialization. As you know that in Gauteng, there are 35 schools that have been earmarked in order to become the school of specialization. We were the number 9 school that was launched on the 9th of April. And the launching of the school gave birth to the following innovation, coding and robotics, multi-skill certificate, innovative projects, leadership and entrepreneur. Also, as I'm saying that it advantages the school also in terms of the academic performance of the school. The school from 4 years back, we have been performing above 90% with an average of 55% bachelor's pass in our school. When you see the stats there, it says 2019 it was 93%, and 2020 it was 93%, sorry for that, 4. 2020 it was 94.6, 2021 it was 95.5, and we have realized that it's possible to go to 100%. Right, during our launching, we had the first series of the project of innovation. I hope some of you have already noticed that we made a buggy, BMW buggy called Tumamina, as you can see the picture there, and it was the world famous buggy in the world. And I've heard that even today in Germany, they've created a buggy similar to that one. Right, that one, as I've said, that we have sponsors also from BMW. They have sponsored with a BMW X3, and currently they've changed it, and they bring the new one. And you can see the layout of the workshop there. On the top there is our own homemade BMW buggy there. Now we are going to offer this opportunity to one of our learners to tell you why solar train. Over to Ronnie. Thank you.
Thank you so much to my principal and also the program director. My name is Masindi Roni, and I'm the one of the students who are participating in the solar locomotive project that we started it in last year in September. So I'm responsible to explain to you about our problem statement that why have we made the solar locomotive train. Right, as you know that in our country, South Africa, the power utility, which is Eskom, is currently suffering from supplying current to the household, and which affect the industries, such as electrical trains, and also objects that uses electricity in order to function. And this results in load shedding. So industries that uses electricity are not able to function. And we know that electrical trains in our country, they use electricity as the main source in order to move. So when we experience load shedding, they are not actually able to move. So this results that our parents, brothers and sisters, they are not able to go to work or from work to home. And also the problem is that the issue of cable theft. This is what we currently face in our communities, and also this affects it has a huge negative impact on the economy as well. And again, without forgetting that the electrical trains in our country, they use diesel as the main source in order for them to actually move. And so they emit a lot of carbon dioxide in the atmosphere. So this is our prototype that we have created using recycled waste materials. These are the boxes. We use boxes and small rocks in order to create the prototype. And what you see here, it is the team. While we were 20 when we actually started with this research and also the literature review. And as I've stated that in our country, we are currently facing a huge impact of load shedding. And this affects the industries that actually uses electricity to actually function. And also stating that it has a huge negative impact on the economy, since, well, people now, they tend to actually lose jobs because they always maybe arrive late at work, or sometimes they might not make it to work, as it is our culture, black culture, that we use trains to actually go to work. And moving forward to our engineering goal, as this is an engineering project, our engineering goal was to create a lightweight train that actually uses solar, that get energy from solar and move at a speed of the train. And the speed of our train is 30 kilometers per hour to avoid the aerodynamic force. So as you know, the aerodynamics is that it is affected at objects that move from 40 kilometers and above. So our train, it actually moves at a speed of 30 kilometers per hour. And yes, now Nkwana Ridumezi is actually responsible to explain to you about how we actually started with this train, from the literature review, the procedure, the background information, and also to the real prototype. So now I would like to actually hand over to Ridumezi, who is also responsible to explain furthermore about the process of our train. Ridumezi.
Good morning, ladies and gentlemen, dames and years, amanene namaninikazi, dumelang bagaetsu. My name is Nkwana Princess Ridumezi, and as introduced, we are from Soshanguve Automotive School of Specialization with an automotive focus. Well, my team and I come a long way. We did a book overview or a literature review for about approximately five minimum sources, where we were able to gather information about how solar locomotive works. Sorry about that. How solar locomotive works. And we even went to Transnet in Pretoria, where we conducted more research about how solar locomotive should function and how we should make all the components come together. Well, we made an operational plan where we made a prototype of our solar locomotive, a small prototype made of boxes on how our actual true prototype should look like. Well, our main component that our operational plan consisted of, it consisted of the sun, the charge control, the motors, the plug-ins, the wheels and the rails. And we also, in our research, identified essential components that must be used in our solar locomotive, where we identified batteries, inverters, motors, motor controls, chasers, and the body of how the body should be conducted. Well, we identified that the most essential things needed by our solar locomotive was solar panels, which uses direct light from the sun for the process of photoelectric effect to take place, where the electrons are ejected from the monocrystalline solar panel to produce electrical energy. And we also have the inverters, which converts electrical energy from DC current to the alternating current, which is the type of electricity that flows in such a way that it alternates. And we also identified the motor, which is the electrical component that converts electrical energy into mechanical energy. And we also build the body. Well, the body of our train is aerodynamically friendly, meaning that it is designed in such a way that it is able to resist the flood of the air that is coming through it, which is mainly made of steel tubes and steel riggers. And this is where us learners were in progress of building the prototype of our solar locomotive. And we also build the chasers from scratch with our own hands. Well, the chasers, which is the base frame of our solar locomotive, which mainly consisted of the axles with differentials and steel rims and steel rails with less rolling resistance. And we also have on suspension, which is the mechanical system of leaf springs and shock absorbers connecting the axles and wheels to the chassis. Briefly, this is us working with the chasers in our school. Sorry about that. Well, briefly, let me tell you about the process of what is happening with our solar locomotive. Sorry for the inconvenience, we couldn't put the pictures on. Well, what is happening is that the sun, which is mainly used as the energy, but then to us, we use this as our light energy for the process of photoelectric effect to take place, where the electrons are ejected from the 4 photovoltaic monocrystalline solar panels of 390 watts each to produce electricity. Well, our monocrystalline solar panels are the most effective ones in the world, if I can say. They are most efficient, and that's why we chose the monocrystalline solar panels. Well, the inverter is then going to convert the DC current from the solar panel, as we know that the current that is from the solar panels is the direct current which flows in one direction, and to convert it to alternating current for it to able to charge the batteries of our solar locomotive. Well, when the 4 lithium ion batteries of 48 volts and 12,000 watts, that's our ratings of our batteries, are charged, they will then supply electrical energy to the motor, where the motor will convert the electrical energy from the batteries to electrical energy from mechanical energy, where it will provide the movement of our train. And what is happening is that we used a 10,000 watts brushless or synchronous motors, which others call it electronically commutated motors, where they will turn the wheels of our solar locomotive, as we know that the job or the work of the motor is to create movement of something. So our DC motor usually uses electronic controllers which switch DC currents to the motor windings, in which the electronic motor rotor rotates, and our motor uses what we call it controllers, which adjust the phases and the amplitudes of the DC current, in which it creates the movement and the speed, which it controls the speed and the torque of the motor. This is where we have the movement of our solar locomotive, as we know that a train is not turned by the steering wheels, but then it's turned by the rails of it and the wheels of it. Well, thank you for listening to me. I will give the platform to Lethabo Nkadimeng, who will further explain to you about the integration of grades and all the knowledge we have to apply in our solar locomotive. Thank you.
Good morning, everyone. My name is Lethabo Nkadimeng from Soshanguve School of Specialization in the Automotive Focus. And my role is to outline what the input of the solar locomotive project has enhanced learning, and also to outline the importance of hands-on learning. Now, what traditional education focuses on? Traditional education focuses on teaching and theory. However, we know that most of what is being taught in classes is forgotten, and much of what is remembered is irrelevant. And so, we, as the Soshanguve School of Specialization, we have been able to apply what we call hands-on learning, which is a form of education where we learn by doing. Because as young as we are, it becomes dull to learn in class and be a sponge by absorbing only theory, right? And what we have here is the mechanical students came together in order to mold the structure of our train. Mechanical technology has also been used in the building of the chassis. Here we have students in electrical technology that had the role of doing the electrical connections of the train, including ensuring that the train itself has electricity. We also have physical science that is important, was used for weight distribution of the train, and also the identification of the forces acting on the train. Right? And then in order for us to have a clear picture of what it is that we were to design, we had to use engineering graphics and design in order to produce an engineering drawing that will then convey important information about our solar locomotive. And then here we have students from civil technology, whereby we use civil in order to build the railway track of our solar locomotive. So what happens is that we have been able to apply hands-on learning in order to produce our locomotive or to come with a solution. And basically what we have done is we have shown that whatever that we learn in school can be applied in real life in order to solve some of the biggest problems that we face in the world. Not only that, but to also enhance our lives. And we have shown as students from Soshanguve Technical that it is all possible. And it all goes down to working together as a team. Now, our takeaway is that we, as people, we can combine together in order to tackle the problems that we are facing in the world. But it all goes down to being solution-minded. Now, being solution-minded is all about having an attitude of mind that is all about coming up with solutions to problems. And then here, after all the application of the subjects in our school, we have been able to have the train completed, and this is actually a video, was supposed to be a video of the train moving. And then as you can see, we have the train moving. And this is all from the result of the combination of the subjects. Well, as you have seen, that is all from the result of the combination of subjects from our school. And basically what happens is students from all their different subjects of specialization have came and contributed what they know and have learned from the subjects in order to produce this new solution. And what we stand is that God be the glory. Without God, this wouldn't be possible. And I stand here to tell you that you can also do something this big. It all takes teamwork, consistency, also dedication to whatever project that you're looking forward to building. And we say to you that you can also create, you can innovate, and you can inspire. So lastly, the question I have to you is, do you think that we can really depend on the solar locomotive in our daily basis? Thank you.